My name is Wasim Muftah Ramadan Shankada. I studying computer engineering. That's our third project in machine learning. Problem overview. We are building a neural network to classify binary digit using TensorFlow KRS. The dataset consists of digit images flattened into 400 pixel vectors with labels indicating whether the digit is a 1 or 0. Our goal is to train a model to accurately classify these digits. This code involves loading, processing the data, building a sequential neural network model, training the model on the dataset, evaluating and visualizing the performance, making prediction and saving the trained model. First step, we import the libraries, the necessary libraries, what we need in our code. Let's import numpy as mb, import TensorFlow as tf, and the another necessary library. NumPy for handling arrays and numerical operations. TensorFlow cares for defining and training and managing the neural network. Matplot library for visualizing, training matrix and predictions. I will be start this code. Okay, and we come now to next step. We load our data by using function load data. The data is loaded from MBY files, x presents the input feature digit images and flattened 400 pixel vectors. Y contains the label label 0 or 1. Only the first 1000 symbols are loaded for faster training. After load our data, normalize x. We normalize x by dividing by 255 to scale pixel values between 0 and 1 for better performance and faster convergence during training. We come to next step, build the TensorFlow KRS model. This is our code. A single model is used to stack layers. This is input layer, takes 400 inputs, features flattened images. Hidden layers. We have two hidden layers. The first layers, or layers 1, has 25 units, each using a segment activation. Layer 2 has 15 units, also using segment activation. The output layer, 1 unit with segment activation output a probability indicating whether the digit is 1. we come to compile the model. This is our code to compile model. Loss function binary cross interby measures the error for binary classification tasks. Optimizer Adam optimizer adjusts weight during training for efficient convergence. Metrics accuracy is tracked to evaluate model performance. Step 5, training the model. That's our code design for training the model. Training runs for 20 epochs iteration over the dataset. Batch size of 32 means the model process 32 samples at a time. 20% of data is received for validation to monitor overfitting. Receives 20% of the data validation. We come to next step, visualizing training metrics. The loss curves for training and validation data help diagnose model performance. A large gap between training and validation losses might indicate overfitting. We come to next step, making prediction and visualize. This is our code to make the prediction and visualize. Random select 64 images from the dataset. For each image, the model predicts a label. Disables the original image and predicate label side by side for easy verification. The next step, save the trained model. The trained model is saved in .h5 format, allowing future use without retraining. That normalizing data ensure faster convergence and better stability in gradient descent. Segment activation. Why segment is used in output binary classification and hidden layers to model nonlinear relationships. The importance of validation data to monitor overfitting during training. Visualizing. How visualizing prediction help assess model performance intuitively. Saving the model ensure reproducibility and makes the deployable for future applications. That was our code. I will start it here. We started to import our library. Next step, I will start it here, the load data. part. Load dataset to x and epsilon. Normalize x for better performance, divided by 255. Build the transfer cares model. Compile the model. Train the model. Train here. This is the result from our model. eBush by 20. That's it. Visualizing and training performance. I will start at this part here to make our graphic. That's our graphic. The blue linear is training loss and orange linear is validation loss. Make predication and visualize. Here visualize the predication x epsilon with our model. This is our predication here. And we come to last part here. We save the trained model and we printed the model as saved. We show the user the model as saved. Model saved as binary digit models, and this is our file, and that was our project 3 for machine learning. Thank you and have a nice day.